Now on to our inverse tangent functions. So the tangent graph we're not as familiar with because we only had to know how to graph sine and cosine. But this is the tangent graph, which you did briefly see. We just haven't worked with a lot. And would you consider this to be one-to-one? Well, once again, nope. So we have to do some restrictions. So these, just to refresh your memory, these little waves repeat themselves, right? Every pi units, blah, 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 it keeps going. So I only focused on one of them. And so that is why mathematicians came up with, from looking from here, negative pi over 2 to pi over 2. The difference is, so it's kind of convenient because it's the same restriction as arc sine. However, tangent can't have negative pi over 2 and the input cannot be pi over 2 because that's where it's undefined. So instead of using brackets, we use parentheses because it can't be those things. It can get really, really close, but it can't be exactly that. So we just look at that interval from negative pi over 2 to pi over 2. And that is how we end up getting that green graph, which is our inverse tangent. Now, when you're looking at just this purple tangent graph, right? What is your domain? Well, it's negative pi over 2 to pi over 2. It can't be those, right? Because that's where it has asymptotes. It's undefined, so it's parentheses. And your range here actually is very different because our graph goes on forever in this direction and in this direction. So our range is all real. So we could either look at our graph for the inverse tangent or just know that the inverse, we're going to swap our domain and range. So our domain is all real. And our range is negative pi over 2 to pi over 2. And again, if we look at our green graph, we'll see, well, okay, our domain, it's everything, right? Because it goes on forever in this direction. But we can also see that it levels off right here. And that's where pi over 2 is happening. And this is where negative pi over 2 is happening. So let's list those values. So we have a chart to refer to. So I'm going to bring up that good old unit circle, get rid of my markings. And when I look at, forgive me, let's see, there it is. When I look at inverse tangent, this nice visual a student came up with, we put circles there to let us know it can't be that. So these are the only two quadrants we're going to look in. So we start at negative pi over 2. This is negative pi over 2. Then it's negative pi over 3. Then it's negative pi over 4. Then it's negative pi over 6. Then we hit 0. And then it's pi over 6, pi over 4, pi over 3, and pi over 2. Okay, well, when you look at negative pi over 2, remember tangent is y divided by x, so that's undefined. Negative pi over 3 is y divided by x. We've done that enough, so we know we should just get negative root 3. Negative pi over 4, negative root 2 divided by negative root 2 divided by 2, then divided by root 2 divided by 2. It's just going to be negative 1. Negative pi over 6 will be negative root 3 over 3. We've done, rationalizing and all that in other sections, so that's why I'm going through this quickly. 0 would just produce 0. Pi over 6, well, 1/2 divided by root 3 over 2 is going to be root 3 over 3. Pi over 4, it's the same thing divided by the same thing, so we just get 1. Pi over 3 is root 3. And then when we're here, 1 divided by 0 is undefined. And so that way we hit all of our outputs, right? And just in that restriction that we came up with. So now inverse tangent of 1, so that's asking, okay, what angle produces 1? That would be pi over 4. Oh, again, I'm very sorry with this notation. I just got too excited. Again, you only do arctangent or do this notation for inverse. You don't do both. I need an editor always. Arctangent of negative root 3 over 3. Well, that's right here. And that angle is negative pi over 6. Okay. So now we're going to the same idea when we compose with our tangent functions and our inverse tangent functions. So again, we have our definition, f of x is tangent of x and g of x is the inverse tangent of x. If I compose this way, remember it means the same thing as f of g of x. Okay, well that would just be tangent is your outside function because it's f, composed with inverse tangent. Again, this thing will spit out the input. However, we have some restrictions. So with the tangent function, remember that is where, that is just, let's just scroll back real quick. Look here, our range for our tangent function is just all real. So life is good. This is where x can be, if you've seen this, all real or interval notation. So that's really nice news. Where before with cosine and sine, it could only be between -1 and 1. Now, if I switch the order, so now my inverse tangent is the outside function. And you can have parentheses around that x or you don't need it. Sometimes you see it and sometimes you don't. Well, remember, let's go back up here. That is where that restriction comes into play. And because we're looking at the inverse function and it's the outside function, it can only spit out between negative pi over 2 to pi over 2. Again, it can't be those values because that's where it's undefined. Okay, so looking at A. So A, my outside function is the inverse function. So I'm looking at property 2. So it has to live between negative pi over 2 to pi over 2. And good news for us, pi over 3 does. So I don't have to think much. It's just pi over 3. However, with this one, it's arctangent composed with tangent of -2 pi over 3. So I'm going to get this up and going. And let me go ahead and erase previous stuff. Okay, so -2 pi over 3. So again, this is +2 pi over 3. So if I'm going negative, I would end up right here. I cannot say this would just spit out -2 pi over 3 because it's not within its range, right? So again, we can only live here and here. Well, we can use that idea of that reference angle, but good news for us, this is on our unit circle, so there's another easier way we can do it. What does tangent produce here? Well, if I do that, it's -√3 over 2 divided by -1/2. That would give me a positive √3. You're either here or here. Where does tangent also produce a positive √3? And that would be right here. So that is why this answer is pi over 3. Now let me use a different way, okay, this idea of a reference angle, because that's going to come into play with some of these problems as we've seen before. Well, to relate it to that reference angle, remember from here to here is your reference angle. Well, if this is a full pi and I'm going to 4 pi over 3, I could make this 3 pi over 3, just so we have a common denominator. So you would just need an additional pi over 3. That's your reference angle. You make a decision. You either go this way for tangent, or we go this way, because that's the only direction I can go in. That's same for inverse sine as well. Cosine was different. I could have gone this way too for cosine, inverse cosine, but tangent doesn't live in that quadrant. That's not the restriction. Well, you think, okay, this thing, forgive me, this thing produces a positive, and so that's why I'm going to go a positive with my reference angle. Okay, now C and D. So C, it's just the tangent function is the outside. So that looks like property 1. And life is good. X can be whatever it wants to be. So I don't even have to think. This would just be -1. And again, another error. This is inverse tangent. So let me go ahead and just rewrite this. Tangent composed with inverse tangent. I really need to hire an editor. Okay, again, sorry, that's my dog. Let me just pause this for a second. So this, because my outside function is tangent, I don't have to think much, it just equals 5. Now, just to compare it, if I had like cosine composed with inverse cosine of 5, this one would be undefined, because it can only go from -1 to 1. All right, here's this beauty. Arctangent composed with tangent of 5 pi over 9. So I'm going to take a look at this unit circle, and I don't see 5 pi over 9 anywhere. Doesn't mean it's not there. It just doesn't produce perfect special right triangles. So 5 pi over 9, again, you got to be good with your fractions. Realize this is a full pi. This would be 9 pi over 9. Okay, so think about it. What is half of 9? Half of 9 is 4.5, right? So that would be right here. But I have 5 pi over 9. So I have a little bit more than a half. So again, I'm not going to, well, let me actually do this right. So yeah, hold on one second. Let's go. Yeah, so I'm totally approximating. I am going to guess it's like right here. That's where 5 pi over 9 is, because remember, from here to here would be 4.5 over 9. So I just need a little bit more. So get fractions, fractions, fractions. I am definitely not living where I need to live. I can only live from here to here, from here to here. So this is why you have to use this reference angle business. Well, if this is 5 pi over 9, I need from here to here is my reference angle. Okay, so again, let me actually, I haven't done this yet, but let me just relate it to things you've done. Here's that angle. That's what 5 pi over 9 is. And remember how we even created the unit circle. We create a right triangle, and we use this idea of this being our reference angle, right? Okay, so if this is 9 pi over 9 and we go to 5 pi over 9, how many more do I need from 9 pi to get to 5 pi? Well, our reference angle is 4 pi over 9, right? Because 5 pi plus 4 pi gives me that 9 pi. So that's your reference angle. Now here you're just, you get to choose, and hopefully you choose correctly. You have an option. Because you're in arctangent world, you either go here to 5 pi over 9, or you use your reference angle and go in a different direction to here. How you make that decision is where 5 pi over 9 is, are your tangents positive or negative? Well, if I did y divided by x in that second quadrant, I would get negatives. So that lets me know I have to choose something that lives in that quadrant, because that's also where tangents would produce negatives. And so that is why this answer is your reference angle, but you're going to let people know that you went a negative angle to put you in the right location. Because what you're saying here is that this angle and this angle will produce the same thing. All right, I think that takes us, to our next video.